All right, so we're going to be solving one-step equations, but this time with multiplication and division. So here my example is 7x equals 21. It's saying 7 times what equals 21? And I got to get x by itself to do that. So I'm going to first draw 7 different x's. 1, 2, 3, 4, 5, 6, 7. So this is 7x. I don't know what x is yet, but... And then on this I'm going to draw 21. I'm going to draw that real quick. Hold on. So here I have 7x is equal, it's balanced with 21. Well, the opposite operation, the inverse operation of multiplication, because there's 7 times x and I need to get x by itself, is going to be division. And so the way I'll do that is I'm going to divide 7x by 7. And if I divide this side by 7, I need to divide this side by 7 too. Now you'll hear a lot of people say, oh, the 7's cancel out. Not necessarily. 7 divided by 7 doesn't really cancel out, it just divides to 1. So what that ends up being is 1x. Now if we know with the identity property, 1 times anything is going to keep the same identity, I can just write x. But I'm just showing you, it doesn't just cancel out, you don't just cross things out. This is 7 divided by 7 that divides to 1. Okay, so 7 divided by 7 gives me 1x. 21 divided by 7 gives me 3. And so in this case, I have x equals 3. If I wanted to show that in my picture, what I would do is I would divide this whole thing by 7, and then that would make one big group right here. And then I divide this side by 7. Well, I have one group of 7 right here. I've got one group of 7 right here. And I've got one group of 7 right here. So I've got 3 groups of 7, which matches what I did down here. Let's take a look at another example. This time I have x divided by 5 equals 6. So I want to get x by itself, so I have to do the opposite. I have to do the inverse operation of dividing by 5. And I'm going to have to end up multiplying by 5. If I did this as a picture, let's draw this big picture. Let's say x is my big number. I'm dividing it by 5. 1, 2, 3, 4, 5. And I basically just have this one piece right here left if I divide x by 5. And then I'm left with 6 here. So let me just draw this like this just to keep the visual the same. 1, 2, 3, 4, 5, 6. So x divided by 5 equals 6. I'm going to multiply because that's the opposite of division. And so the way I can write that is I can just say 5 times x over 5 and 6 times 5. Again, you don't just say that these cancel out. Instead, you can just say 5 times 1/5. You can think of this as 1/5. Multiplies to 1, so 5 times x over 5 is equal to 1x, and 6 times 5 is equal to 30. Really, this is getting into multiplying fractions a little bit, but if you remember 5, we can think of this as 5 over 1. This ends up being 5x over 5, and then 5 over 5, 5 divided by 5 gives me 1. So that's how I got the 1x. So basically, since x is divided by 5, I have to do the opposite of that by multiply by 5. And that ends up leaving me with x is equal to 30. Okay. And in my picture here, if I'm going to multiply this by 5, 1 here, 2, 3, 4, 5, multiply that by 5. And then if I multiply this by 5, that gives me 2, 3, 4, 5. Each one of these has 6 in it. I'm going to go 1, 2, 3, 4, 5. 1, 2, 2. Not the best picture, but you get the idea. That gives me 30 over here, gives me x over here, and that gives me the full x equals 30. All right, let's try one more. So this one, there's going to be 2 ways we can solve this. It's a little bit different because I don't have my x in my numerator, I have x in my denominator. But let's try a few different things. I'm going to wait to draw the picture last just because I think the picture may end up confusing us more in this one. So 12 divided by x equals 4. So let's try something. Let's say if I wanted to get x by itself, I'm going to multiply both sides by x right here, by x. Now what this ends up being 12x divided by x equals 4x. But anytime you have a number divided by itself, 12x divided by x, x over x is equal to 1. So that's like saying 12 times 1 is equal to 4x. And then I can just call this 12 is equal to 4x. From here, now I can actually divide, because 4 times x is equal to 12. I need to get x by itself. This little trick here, I got x over here, and now I can get it by itself a little bit easier. So since I'm multiplying here, I need to do the inverse operation and divide both sides by 4. Divide by 4. 4 divided by 4 divides to 1. And so that gives me 3 is equal to 1x, or 3 is equal to x. The other way that I could have done this problem, let's say 12 divided by 12. Why does it keep doing that? Come on, black. 12 divided by x is equal to 4. I can find the multiplicative inverse of both sides. If I find the multiplicative inverse of one side, I have to do it to the other side. The multiplicative inverse of 12 over x is x over 12. Multiplicative inverse basically flip the order of the fraction. Multiplicative inverse of 4 is 1/4. Remember, multiplicative inverse is what you have to multiply a number by to get 1. So 4 times 1/4 equals 1. Or you can just think of it as just flipping a fraction. This isn't a fraction, but you can think of it as 4 over 1 and 1/4. So now this problem is like the previous one, where I can now multiply both sides by 12, because this is x divided by 12. The inverse operation, it says I need to multiply both sides by the same thing to keep things balanced. X divided by 12 times 12 gives me 12x over 12. And then 1/4 times 12 gives me 12 over 4. The way this ends up working itself out is 12 divided by 12 gives me 1x, and then 12 divided by 4 gives me 3, and then in this case x equals 3. So these are two different ways. You can just get x, move x to the other side by multiplying both sides by x and then dividing by 4. Or you can find the multiplicative inverse of both sides. I'll show you. This was 4 over 1, and then I just flipped them. If you do you need to do the multiplicative inverse to both sides, though, if you're going to do this method to solve for x. Showing a picture, I can just draw 12 to start out with. 2, 3, 4, 1. Oops, there we go. 12 right there, and then my divided by x. I'll show you how to do that. And then my answer of 4. 1, 2, 3, 4. If I know that x is 3, that's basically saying 12. This is not. Accidentally drew 16. That should be 12 right here. Well, let me cut the top off right here. That'll be easier. All right, so that's 12. And then if I'm doing 12 divided by 3, I could just make groups of 3, or 3 groups right here. 1, 2, 3. And each group has 4 in it, which shows that these are balanced right here. The picture's a little bit harder to do when you're doing division, but this is what it would end up looking like. So that's solving one step, but kind of two-step equations using multiplication and division.